Electron binder jetting uses an inkjet print head to apply a liquid bonding agent onto thin layers of powder. By gluing the particles together, the part is built up layer by layer. A binder jetting machine will distribute a layer of powder onto the build platform. The liquid bonding agent is applied through inkjet print heads bonding the particles together. And like many of these processes, the build platform is lowered for the next layer of powder to be put on top of it, and the process is repeated. The advantages of binder jetting is that it's fast and cheap, has a wide range of material types, works with almost any material that's available in powder form, and full color parts are possible. The disadvantages are parts coming directly from the machine have limited mechanical characteristics. Parts are basically glued together, resulting in fragile parts with limited mechanical processes if no further post-processing is done. Typical applications are for prototypes, green parts, as in casting patterns, and molds and cores. The material jetting process, again, uses an inkjet print head to jet melted wax materials onto a build platform. The material cools and solidifies, which allows the layers to be built on top of each other. Material jetting has good accuracy and good surface finish. Its disadvantages are it's a limited number of wax-like materials available to print. The parts are fragile and it's a slow building process. Typical applications are prototypes, casting patterns, and lost wax casting, such as in the jewelry and dental industries. The POLYJET or photopolymer jetting process, again, uses an inkjet print head to jet liquid polymers onto the build platform. The material is immediately cured by UV lamps and solidified, which allows the build layers to build upon each other. Its advantages are multiple materials can be jetted together, allowing multicolor and multi-material parts. Functionally graded materials are possible. Multi-material and or multicolored parts. And we can achieve good accuracy and surface finishes. The disadvantages are this does not work with the standard materials, but with UV active photopolymers, which are not durable, and over time they degrade in the sunlight. Because it works with UV active photopolymers, they won't last and they have limited mechanical properties. The STEREOLITHOGRAPhy process uses a UV laser curing a liquid photopolymer in a vat. The part is built by lowering the build platform into the vat, and with each layer, again, a wiper wipes the top layer clean and flattens it out. The advantages of this process are a wide range of materials, very good accuracy, surface finish, and part detail. The machines with large build volumes can make large parts. And the disadvantages, again, it only works with photopolymers. So the mechanical properties of the part are not stable over time and they degrade in light, and the materials are very expensive. The process is also very slow. Typical applications for this are prototypes and casting patterns. The POLYJET process is often used for prototypes, casting patterns, and tools for injection moldings for short runs.